Hello everybody to the Advanced Case Setup Session E. I will go directly into medias res, what I would like to do with you in the next 10 minutes. I would like to show you how you prepare multiple STLs to be used later in snappyHexMesh. I would like to suggest some naming of files that is useful, and also I would like to show some wildcards that you can use in snappyHexMesh to make your life easier. The second part is going to be efficient case setup using wildcards. I will show you grouping versus usage of wildcards and also as example simulation. I have already prepared the case for you in FreeCAD. This is the case. We have here a simple flow container. I will show you here. We have here an inlet, then we have two outlets, then we have a bottom and a side wall, STL wall. You see it here and here. This can be used, for example, to employ different temperatures at the wall. Then we have the inlet. I have showed you already. This is the inlet. Then we have internals, which are also often interesting. I have already prepared the mesh. You see here I've grouped into two different types of internals that can also be used to use them or not when running snappyHexMesh. And you have seen the outlets here and here. I have already exported the STL files, and I will just show you now the snappyHexMesh case. I prefer to differentiate between meshing and flow simulation. You see it here. I have two different directories. So for the meshing, you see the setup here. Let me open the snappyHexMesh dict. These are old files. I will close them. Bum, 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 bum. So what I suggest for the snappyHexMesh is that at the top you specify variables for the refinement levels. This is very useful later if you do the refinement. Here we specify the geometry. You see all the STLs that are that I've generated. And the first important thing is that you can aggregate multiple STLs to one object in snappyHexMesh. This is shown here. So I have two internals for the STL. These are the STL files, but the name is the same. You see the name here and here. Yeah, this name is the same. So what OpenFOAM will do, it will simply aggregate these two STLs into one object that you can then refer to, and this will be called STLs for .internal. The others are straightforward. We have here the side wall, the bottom, then we have the inlet, and have the outlets, and I have put the outlets into two separate objects in snappyHexMesh. Then here for the features, I have also prepared a surface feature extract dict where I extract the surface features. These are referenced here. And then for the refinement levels, you can now use these wildcards. You see it here, which is very, very useful if you have a large number of different outlets or a large number of walls. Also, please note I use here the grouping. So I put the outlets, all the outlets in the outlet group, and all the walls are also put in the additional group walls. Again, note I use here these variables that I have defined at the very top of the snappyHexMesh dictionary. This is it. The only additional information that you need is a location in mesh. If you make it smart, then you can always do it that the location in mesh is at the origin. That's it for the snappyHexMesh file. I think it's doable for you. And again, use these dots because later you can use the wildcards like this.